So let's talk about something that's, well, fundamental to pretty much everything. What exactly is science? I promise you, it is so much more than just bubbling beakers and lab coats. It's a way of thinking, really, a tool that has totally shaped the world we live in. And the whole thing really kicks off with this one giant question. We all have things we hope are true, right? Feelings, beliefs, opinions about how everything works. But how can we tell the difference between what we want to be true and what's actually true? I like to think of it like this. Imagine trying to make sense of the universe is like trying to organize a super cluttered garage. It's just a total mess. It's chaotic, there's stuff everywhere, and it's almost impossible to know what's valuable and what's just junk. If you're going to sort through all that, you need a system, a reliable one. That system, it's all built around a search for truth. But here's the catch. Before we can even start, we have to get one thing straight. Not all truths are the same. Okay, so on one hand, you've got personal truths. These are things like your favorite song or your opinion on a movie. They're based on your feelings, your beliefs. They're totally true for you. But then there's another kind, objective truths. These are facts about the world that are true for everybody, whether you like it or not, whether you believe it or not. The fact that the Earth orbits the sun, that's an objective truth. And when it comes to digging up those objective truths, humanity has invented one single, incredibly powerful tool for the job. And yep, you guessed it, it's science. So what does that actually mean? Well, at its core, science is just a process. It's a way of explaining the world around us using natural causes. And this is the absolute key, those explanations have to be testable. You have to be able to check if they're right or wrong. That's what gives science its power. It's what allows us to make genuinely useful predictions about everything from the weather to what medicine will make you feel better. So, how does this whole thing actually work? It's not just random guessing, right? Nope. It actually follows a kind of instruction manual. We call it the scientific method. Step 1 is all about curiosity. It starts when you see something that makes you go, huh, that's weird. Maybe you notice your phone battery dies way faster when it's cold outside. The first step is just asking the question, why does that happen? That's your starting point. Next up, step 2, you do your homework. You hit the books, you go online. Because chances are, you're not the first person who's wondered about this. You see what other people have already figured out. So you're not starting from total scratch. You're standing on the shoulders of giants, as they say. Okay, now you're ready for step 3. You form a hypothesis. Now, this isn't just some wild guess. It's an educated guess. It's a specific, testable prediction. So for our phone battery thing, a hypothesis might be something like, cold temperatures slow down the chemical reactions inside the battery, which reduces its power output. See? Specific, testable. And how are you going to test it? Well, that brings us to step 4, the experiment. This is where you design a fair test. You control all the different factors you can so you can really zero in and see if your hypothesis holds up when you put it to the test in the real world. Now, while your experiment is running, you're on to step 5. You just observe and collect data. You're gathering the cold, hard evidence, the numbers, the measurements, the raw facts. This is the stuff that's going to tell you what really happened. Once you have all that data, you get to step 6, drawing a conclusion. You look at all the evidence you gathered, and you ask the big question, was I right? Did the data support my hypothesis, or does it tell a completely different story? And finally, we get to what might just be the most important step of the whole shebang. You communicate your results. You share what you did and what you found. Why? So other scientists can check your work, try to replicate it, challenge it, and maybe even build on it. This is what makes science a team sport. It's how it corrects itself and grows. But, it's really important to remember that this whole process is hardly ever a straight line. It's messy. A lot of times, an experiment will just lead to a brand new question, and you have to loop back and tweak your hypothesis. That cycle isn't a failure. It's actually the engine that drives discovery. Now, understanding this process also means we have to get the language right. So let's take a second to clear up 2 of the most confused, most misused words in all of science: hypothesis and theory. Okay, so a hypothesis, like we've been saying, is that initial, testable, educated guess. But a theory in science? Whoa. That is the ultimate goal. When you hear someone dismiss something as just a theory, they're getting it totally wrong. A scientific theory, like the theory of gravity or germ theory, is a huge, powerful explanation for some part of the world that is backed up by mountains and mountains of evidence. It's the best explanation we have. And this points to one of science's greatest strengths, which sounds kind of weird at first. Every single scientific claim has to be falsifiable. That just means there has to be some kind of test or some piece of evidence out there that could, in theory, prove it wrong. Even our strongest theories, like gravity, are always open to being challenged if new data comes along. Being willing to be proven wrong isn't a weakness of science. It's a feature, not a bug. Okay, so we've talked about the process, the language, but why should any of us care? What's the real-world payoff for thinking this way? Well, the answer is literally all around you. Science and technology are this incredible dynamic duo. Science gives us the basic understanding of how the universe works, and then technology takes that knowledge and uses it to build amazing tools, like, say, the very device you're watching this on right now. And then those new tools let us make even more amazing scientific discoveries. It's this awesome, powerful cycle of progress. Finally, to really, truly get what science is, it's just as critical to know what it isn't. And this is huge. For starters, science does not and cannot make moral judgments. For example, science can give us the know-how to clone an animal, but it can never, ever tell us if we should. It's a tool for figuring out what is, not what ought to be. That's a job for ethics and philosophy. And just like we said at the very beginning, science is not based on personal opinions or beliefs. How you feel about gravity doesn't matter one bit. If you step off a building, the outcome is going to be based on objective reality, not your personal truth. So, in the end, science isn't just another subject in school. It's a mindset. It's a process. And it is, without a doubt, our most reliable tool for cutting through all the noise and confusion to find out what's real. It's the best method we've ever come up with for understanding the universe and our place in it. Which kind of leaves us with one last big thought. We've got this incredible tool. So what's the next big question you think we should try to answer with it?